Okay, so we do need to make sure we understand function notation and transformation. So we're starting with original function square root x. And then we have the inside and outside transformations. I'm just going to start with the outside because the outside is nice and easy, right? So my change in y is going to be, I'm going to times my original square root function by -2. So I end up with 0, -2, -4, -6. So I transfer my x's and my y's separately. My x's are the inside part. There's lots of different ways to do it. I can undo all this algebra. The notation is exactly opposite of what I'm actually going to do. Okay, I could put this into factored form and just do it always as shift first, and then, expand, compress first, shift last. So I think I'm going to do that for this one here. So I'm going to change my notation here. Okay, so I'm just going to not undo anything. I'm just going to change the notation. Okay, so it becomes 3x minus 6 over 2 plus, and I'm going to write that 1 as 2 over 2, and then I can just put that all together. So I get 3x minus 4, okay, all over 2. And then in factored form, the 2 is already factored. If I just factor out the 3, I get 3 over 2 x minus 4/3. And now these two expressions, in fact, this expression and this expression are exactly the same, but one is in the factored form. So I can just do this as compress by 2/3, shift to the right 4/3. So this is one way to do it. The other way is I can undo all this notation and do everything backwards. That would be the other option. So there's a few options here. So I'm going to rewrite this equation. I'm going to write this as y equals, okay, the -2's on the outside. I've already dealt with that. Okay, square root. Okay, so instead of writing this part here, all this is going to be converted into 3 over 2 x minus 4 over 3 factored form. So I know the process of this is going to be, the first step is change in x is going to be, it's a horizontal compression by 2/3, and then shift last, horizontal shift plus 4/3. Okay, so I'm just going to apply that. So it's going to times it by 2/3 and add 4/3. So 0 times 2/3 plus 4/3 is 4/3. 1 times 2/3 plus 4/3 is 6/3, or 2. I get 4 times that is 8/3 plus 4/3 is going to be 12/3, or 4. That's going to be 18 plus 4 is 22/3. Okay, so this is very useful to do factored form. When you actually undo the algebra here, you actually get the calculation to actually do the transformation. So if I were to actually do the change, it would look like this. So this looks like this. So 3x, this is actually my new x, and this notation actually gets me back to my old x. Okay, this is the way that the order in which this happens through the function flowchart. It's actually going backwards through the function flowchart, so I actually need to solve for the other x. So I'm going to do this in steps. So I'm going to end up with -1 times 2 so that's going to be plus 6, and then it's going to divide everything by 3. Okay, and this calculation will give me the exact same transformation as I got here. So I can take all these numbers, put them through here, and I'm going to get those exact same numbers here. Okay, so any way you do it's perfectly fine. Just make sure you understand the idea of transformation. Good to know the factored form. And once I've done this transformation, I'll just plot these points, it's going to be 4/3, 0. Okay, 2 over, 2 down. 4 over, 4 down. That's going to be 7 1/3. So 7 1/3 is going to be 4, 5, 6, 7 1/3. -6, right about there. It's going to be, this graph is going to look like that. Okay, so there it is. There's my transformed graph.